exist. So if I have a right triangle there are certain relationships that always exist and will always contain the same ratio for those angle measurements. So if I have a triangle here and it is not a 30-60-90 or a 45-45-90, let's just say it's a 50 and a 40. Would that be a right triangle then?
Yeah.
Okay. We are going to label these angles this way, A, B, and C. There are certain ratios that will always exist that have the same measurement for any size triangle that may be, say, 40, 50, 90, like this one being 40, 50, 90. Because this triangle would have to be proportional to this one, right? Similar because the angles. Remember when we set up ratios of certain things to certain things from one triangle to the other? Well, those can also exist within a single triangle. They are called trig functions. There are 6 of them. The names of those 6 functions are the following: sine, cosine, tangent, cosecant, secant, and cotangent. Okay? Those 6 functions are always the same. Always. Now, they do give these abbreviations. This one is called sin, which we call sine. So if you come in here and say, I can't find the sin, well, I can tell you probably where you need to look.
The Bible, I don't know.
Why would you look in the Bible for sin?
Cosine,
Answer.
the 3-letter abbreviation for cosine is COS.
You mean God, boy.
For tangent, it's TAN. Cosecant is CSC. Secant is SEC. Doesn't mean the Southeast Conference. Cotangent is cot. It's not what you're going to sleep on either. Okay? What? These 6 definitions that are right here exist for any non-right triangle or any non-right angle in a right triangle.
Say it 5 times fast.
You say it 5 times fast.
I don't even know what you said the first time.
Sine, cosine, tangent, cosecant, secant, and cotangent, all 6 of those definitions will exist for any non-right angle in any right triangle. So there are 6 definitions here. There are 6 definitions here. Okay? This side is an A, this side is a C, this side is a B. Why do I label them A, C, B as little? Because generally we label sides little letters. Okay? If I'm worried about angle A, this is a 6, this is a B, this is a 6, this is an A, that's a C.
Oh my God.
Why are they sixes? There are 6 definitions for each angle.
Sorry.
Okay? So if I'm worried about angle A, we said there are these 6 definitions, right? Each one of these are a ratio of sides in that triangle. So if I'm looking at the sine of angle A, the definition of sine is opposite over hypotenuse. I'm going to start using abbreviations. Okay? So if I looked at the sine of angle A is the opposite over hypotenuse, and I'm back up here to this triangle, and I went here to angle A, what's the opposite side?
Side A.
What's the hypotenuse side?
B.
Little b. So it would look like little a over little b. Okay?
Alrighty.
That's not so hard now, is it? It's just a ratio. Cosine of B, cosine of A, which means I'm still working with this A angle. Cosine is equal to adjacent over hypotenuse. So up here in this triangle, you actually have 2 adjacent sides, don't you? There's this side and this side that are adjacent to it.
So it'd be little.
But one of them has a specific name. This one has a specific name called the hypotenuse, doesn't it? So do you think I'm going to use that in the definition as adjacent? No. So adjacent side in this case would be what?
C.
C over the hypotenuse, B.
So if you're working with angle B, which one would be the opposite? Which one would be?
You never find a trig function for a right angle.
Oh, you don't.
Never find it for a right angle. That's why I said it's always the 2 non-right angles in a right triangle. Okay? So you never use it. Tangent of A. Tangent of A has a definition of adjacent. I'm sorry, I got it backwards. Opposite over adjacent. Okay? Going back to the triangle, here's angle A, right? Angle A, what's the side opposite to angle A? And what's the side that's adjacent? Little c. So the tangent in this case of A would be A over C. Alright? So far so good? You got those? The sine is opposite over hypotenuse, etc. These definitions right here, we're going to go through these others, but these right here have an acronym that goes with it. SOHCAHTOA. SOHCAHTOA.
We learned about that in Tom Baylor.
I had to remember that in a couple of the C4Os. They had like that.
Okay, means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent.
Yep. I got my unicorn story. Still in my flash drive. You still have it? That is so funny.
I heard your voice though.
What?
When she was presenting.
She was laughing. I was laughing so hard.
We okay? Out of these 6 functions, generally the ones that you use the most are these 3. Okay? You will use those 3 the most. Getting rid of that, we want to find cosecant of A. The definition of cosecant is the inverse of sine, which means that it would have been hypotenuse over opposite. Which means up here, if I looked at angle A, I want hypotenuse, which would be B, side B, and the opposite side would be A. So for this particular diagram, cosecant of A would be hypotenuse over opposite, which would be B over A. Secant of A is the inverse to cosine. Well, cosine was adjacent over hypotenuse, so if I inverted that, I would have hypotenuse over adjacent. So going up to angle A, what would be the hypotenuse? And the adjacent side would be C. So I'd have B over C. Cotangent of A is the inverse to tangent, which means that it will be adjacent over opposite. Okay, A, what's the adjacent side? And what is the opposite side? A. Right? So in this particular diagram, the cotangent of A equals adjacent over opposite, which would be C over A. Okay? All right. I can now find sine of C. So by the definition that we just got done with sines, what's the definition of the sine?
Opposite over hypotenuse.
Okay, opposite over hypotenuse. So if I looked at the opposite side to sine to angle C, what would that be? And the hypotenuse would be? Then I need to find cosine of C. Definition? Adjacent over hypotenuse. So if I go to angle C here, what's the adjacent side? What's the hypotenuse? So now I want to find the tangent of C. What's the definition of tangent? So what's the opposite side? Adjacent side? Cosecant of C we said was the inverse to the sine of C, didn't we? Well, if it's the inverse, it would be B over C. Secant of C we said was the inverse of cosine, which would be B over A. cotangent of C, we said was the inverse to tangent, which in this case would be A over C. We good with those?